Again, a number of you asked about solving systems using graphing. So I'm going to kind of kill two birds with one stone with this system of inequalities, 6A and B, for the 2015-2016 test, because it allows me to demonstrate a little bit about how to graph linear equations while also demonstrating how to graph linear inequalities and how to figure out if a point is in the solution for the system of inequalities. So we're going to graph these initially just like lines. So I'm going to start with this inequality, and I'm going to treat it like an equation. So if I treat this like an equation, like y equals that, I have a slope of 1/3 because this is in the slope-intercept form, and I have a y-intercept of 3. So that means I have a point on the y-axis at 0, 3. So let's go ahead and plot what that tells us here. I have a point at 0, 3. If my slope is 1/3, that means that I'm going to go up 1 and over 3. So I'm going to have a point at 3, 4 now. I can also go plot my 1/3 slope backward, so down 1 and back 3. So I'd have a point here at -3, 2. And since this is an or equal to, then those 3 points are actually solutions to the inequality. They would make the inequality a true inequality. So I could plug in any one of these x, y values and replace the variables and get a true inequality. So my next step is to figure out which side of the inequality is going to be shaded, which side is the set of all points that are true. So is it this side or this side? I already know that I can make an equation at y equals 1/3 x plus 3. I know that equation is part of the inequality because it's an or equal to. And now it's just about testing which side. So we're going to test whether 0, 0 works, because 0, 0 is not on the line and it's really easy to work with. So I'm going to replace y with 0. I'm going to copy the rest of this down here. And I'm going to replace x with 0. And I'm going to solve that. What that now says is 0 is less than or equal to, so it's 1/3 times 0 is 0. We're saying 0 is greater than or equal to 3. Greater than or equal to 3. That is not true. So 0, 0 is not in this system. 0, 0 is on the wrong side of our boundary line for, sorry, 0, 0 is not in this inequality. 0, 0 is on the wrong side of the boundary of our inequality, which means everything on the other side up here is in the inequality. So this is a greater than or equal to. So I'm going to just go ahead and plot it, and you can see it's greater than or equal to, and yes, it's graphed above it. Now, let's take a look at the other inequality. The other inequality is also in the slope-intercept form, which is very convenient for us. I'm going to copy that down here. Okay, if this is the case, in slope-intercept form, again, we know the slope-intercept form is y equals mx plus b. So -4/3 is m. It is the slope. And b, the y-intercept, equals -2. So there's a point at 0, -2 on the y-axis. So let's plot 0, -2. And we know we have a slope of -4/3. So that would be down 4 over 3. So from 2 to 6, negative 2 to negative 6, and then over to 3. So 3, negative 6 is another point. And I'm going to backtrack also. I'm going to, instead of down 4 over 3, I'm going to go up 4 and back 3. You might already see we've run into this point. So we've got negative 3, comma, 2. Okay, so now I've got all of those points, and that means I can make a line that goes through it. So y equals negative 4/3 x minus 2. And that goes through all those points. Now, you might have noticed that this is not an or equal to inequality, so we can't actually include the points on that line as part of the inequality. The inequality gets right up to them, but cannot actually touch that. So when I do my inequality, I need to change this line to a dashed line, and these points to empty holes. They are not actually part of the inequality. And when I change this instead into an inequality, I need to figure out which side of the inequality is shaded so that I can figure out where the system is. So I'm going to test a point. I'm going to test 0, 0 again because 0, 0 is not on the line. And so let's test that out. So to test 0, 0, I just need to replace x with 0 and y with 0. Okay, so 0 is less than negative 4/3 times 0. Well, that means 0 is, so the negative 4/3 times 0 is nothing. So now we're saying 0 is less than negative 2. 0 is definitely not less than negative 2. So that means this side is not shaded, but this side has to be. So we're going to change this into its inequality. And there you have it. You have the system of inequalities, which happens to be the overlap between this inequality and this inequality. Now the last step is 6b, which is we want to figure out if a particular point is a solution for this system. Is 7, 6 a solution? So I'm going to plot 7, 6 and see if 7, 6 is in the solution area. Well, it is in the first inequality, but it is not in the second one. And so it's not in the overlap zone that is the solution area of the systems of equations. So 7, 6 is not a solution for that system. Nope. Not in the solution zone on the graph. I hope that helped you understand a little bit more about how both to graph lines and how to graph inequalities and solve systems of inequalities.